Welcome to qnawire.
Hi, so over here we're given the formation constant for the flowing complex, in which the reaction would correspond to cobalt 3 plus in aqueous medium plus 6 equivalents of NH3 in aqueous medium that is going to produce the associated complex. Let me put a bracket NH3 6 3 plus as well in aqueous medium. For this reaction, the formation constant is the value provided of 1.58 times 10 to the 35. At 25 degrees Celsius. So now we're going to suppose that we're going to combine equal volumes of cobalt nitrate and of NH3. That means that since the volumes are the same, the final volume would be equal to 2 times the initial volume for each of the solutions. Thus, the concentration is going to be diluted by a factor of 1/2 for each of them. Thus, the concentration of cobalt 3 plus would be equal to 0.0012 molar, and the concentration of NH3 would be equal to 0.40 molar. As you see over here, the value for Kf is going to be a super high number. That means that almost everything is going to get into the cobalt complex over here. So in these scenarios, what you need to do is to, first of all, assume that everything is going to that the complex is formed quantitatively. We're going to have a quantitative formation quantitatively. Sorry, over here I missed a syllable. Quantitatively, meaning that we're going to have only a small amount of cobalt 3 plus that we're going to be having into the solution. So in order to do so, let's go with a simplified table. The initial concentration would be 0.0012. Clearly, the cobalt 3 plus is going to be the limiting reagent for this reaction, since we're going to have so much less of cobalt 3 plus. The amount of change is going to be minus 0.0012 minus 6 times 0.0012 and plus 6 times, and plus 0.0012. So at equilibrium we would get 0, 0.3928, and 0.0012. And now we're going to look at the reverse reaction. Why we're going to do so? Because in that way we're going to be able to have a value of Kf that is of an equilibrium constant that is going to be super small instead of being a large value. So if we look at the opposite reaction, going into cobalt 3 plus 6 of NH3, now the equilibrium constant would be equal to 1 over the formation constant, which is going to give us 6.329 times 10 to the minus 36. Now we're going to use the initial concentration of what we assume that was formed of the complex. We're going to assume that we're going to have 0 of cobalt 3 plus and 0.3928 of NH3. The amount of change is going to be equal to minus x plus x and plus 6 times x. So at equilibrium, we're going to end up with 0.0012 minus x, and 0.3928 plus 6x. If we were to write down this equation, the equilibrium constant, which is equal to the value that I just mentioned, 6.329 times 10 to the minus 36, would be equal to concentration of NH3 to the 6 times concentration of cobalt 3 plus divided by the concentration of cobalt NH3 6. Notice that if we replace the values directly with the 6x and with the minus x over here, we're going to have a polynomial of degree 6, which is not going to be easy to solve. But what we can do now is that since the value of x is going to be so small, due to the equilibrium constant telling us that it is going to be a very small fraction at the end, what we can say is that 0.3928 plus 6x would be approximately equal to the value, and that 0.0012 minus x would be equal to approximately 0.0012. And with this, we're good to go. So under this approximation, equal to 0.3928 to the 6 times x divided by 0.012. Thus, x would be equal to 0.0012 times 6.329 times 10 to the minus 36 over 0.3928 to the 6, which gives us 2.0677 times 10 to the minus 36. And this would be equal to the molar concentration of cobalt 3 plus after the complex is formed. Now in this case, we're asked to round up to two significant digits, so this would be approximately 2.1 times 10 to the minus 36 molar. And with that, it would be all. Just as out of curiosity, if you solve the complete equation with non-approximation, you're going to get the same result. This means that our approximation is actually valid, and you're going to get two answers that are negative values, and everything else are going to be complex solutions for the equation, which are going to have no physical meaning. So, with that, it would be all. This is the final answer. Thank you very much, and have a good one.